Hello everyone, welcome in this video lecture. This is Bhaskar Ankush, Assistant Professor in Chemistry. Here in this lecture, in this video, we will see the chapter of physical chemistry, that is entropy or concept of entropy in the syllabus of BSCSY. This is the unit 3rd, the concept of entropy. In previous lecture, we have seen what is meant by entropy, quantitative definitions of entropy, etc. Now, in this lecture, we are going to see the calculation of entropy of an ideal gas as a function of P, V and T, or with change in the pressure, volume and temperature. Entropy is nothing but it is the state function. State function means its value depends upon the initial and final state and not on the path. Entropy is the state function and it varies with the variables of the state, pressure, volume, temperature, etc. It is always depends only upon the any two variables, that may be pressure, volume or temperature. Now we will see the one by one. First one, the change in entropy when the two variables temperature and volume, or entropy change of an ideal gas as a function of temperature T and volume V. The increase in entropy of a gas for an infinitesimal small change is given by the equation. म्हणजे इन्फिनिटेसिमल स्मॉल चेंज म्हणजे खूप कमी प्रमाणात थोडा जरी चेंज झालेला असला एंट्रॉपी मध्ये, तर आपल्याला तो डिटरमाइन करायचा बाय युजिंग इक्वेशन. व्हॉट इज मीन बाय एंट्रॉपी? इट शुड बी known for us, that is we should know what is meant by entropy. Entropy is nothing but the randomness of the molecule in the system. जो काही गतिमान मॉलिक्युल्स असतात त्याची चंचलता, डिसऑर्डरनेस, randomness of the molecule in the system is called as entropy. Now this is given by this equation. ds is change in entropy is equal to dq reverse, that is heat is absorbed by the system upon absolute temperature T. According to the first law of thermodynamics, we have the equation, the total internal energy of the system dE is equal to heat absorbed dQ plus work done on the system dW. That dE equal to dQ plus dW. If the work is involved is due to the expansion of the gas, then an infinitesimal increase in volume dV against a constant pressure P. Then as we have this equation of the first law of thermodynamics, then as work done expansion म्हणजे काय, तो गॅसचं व्हॉल्यूम वाढणे. गॅसचं व्हॉल्यूम वाढतो म्हणजे त्यामधला पिस्टन हा आउटसाइडला ढकलला जातो. म्हणजे इंटरनल जो काही सिस्टीम मध्ये गॅस आहे त्याचा प्रेशर वापरलं जातं. दॅट इज वर्क डन बाय द सिस्टीम. वर्क डन बाय द सिस्टीम असेल तर त्याचं सिम्बॉल आपण मायनस घेतो, कारण सिस्टीमची एनर्जी यूज होते, सिस्टीमची एनर्जी खर्च होते त्या ठिकाणी. देअरफॉर द वर्क डन बाय द सिस्टीम मीन्स इट शुड बी टेकन एज मायनस P into dV. Also we have the equation CV, that is heat capacity at constant volume is equal to dE upon dt, or dE we can rearrange this equation. dE is equal to CV into dt. By putting this value, here जर व्हॅल्यू आपण इक्वेशन मध्ये ठेवल्या, हा dE equal to CV into dt इथे ठेवायचं, आणि हे dw हे जे आहे इथं प्लस मायनस मायनस होईल. हे dq म्हणजे इक्वेशन काय येईल आपलं, बाय पुटिंग दिस व्हॅल्यू ऑफ dE and dw in the above equation number 1, then we will get this equation CV into dt is equal to dq. हे नंबर 1 चं इक्वेशन, त्याच्यात फक्त आपण हे व्हॅल्यू ठेवत आहोत, dq minus P into dV. or हे Q जर आपण इक्वल टू घेतलं तर हे जे काही पी डी व्ही मायनस आहे हे इकडे आल्याच्या नंतर काय होईल प्लस होईल dq इज इक्वल टू cv इंटू dt प्लस dv. Or by putting the value dq or dq is taken as dq reversible, that is heat absorbed in the reversible manner. dq reverse is equal to cv into dt plus dv. This is we can say as equation second. The ideal gas equation, we have ideal gas equation PV is equal to nRT, P is pressure, V is volume, N is number of moles, R is a gas constant and T is the temperature of that system. N is the number of moles. For the 1 mole of an ideal gas, that is N is equal to 1, there is no need to write here 1, or by multiplying to any value by 1, that value remains as it is. Therefore, PV is equal to RT for the 1 mole of an gas. So P is equal to RT upon V. By putting this value of P, आता हे जी काही P ची व्हॅल्यू आलेली आहे हे कशावरून व्हॅल्यू काढली आपण, जो आयडियल गॅस इक्वेशन आहे त्यावरून P ची व्हॅल्यू काढली फॉर 1 मोल ऑफ गॅस. P is equal to RT upon V हे इथं ठेवायचं या ठिकाणी इक्वेशन 2 मध्ये. Then by putting this value of P in equation 2, we will get the equation 3, dq reversible is equal to cv into dt as it is हे बाकी सर्व सेम. हे P च्या ठिकाणी RT upon dv upon V हे जे काही आहे इथं dv त्या खाली ते V येईल. RT into dv upon V. By dividing the above equation number 3 by capital T on both sides, then we will get this equation ds is equal to dq reverse upon t, or it is equal to cv into dt upon v. हे जे अगोदर आपण dq upon e नंबर 1 ला इक्वेशन लिहिलं आहे त्यावरून हे इक्वेशन तयार होतं. हे जे काही वरचं इक्वेशन आहे त्याला आपण काय केलं, डिवायडेड बाय टी केलं. इकडच्या साईडला पण डिवायडेड बाय टी, इथं पण टी आणि इथं आर टी अपॉन टी. आता या इक्वेशन मध्ये जे आर टी अपॉन टी आहे हे टी टी कॅन्सल होईल, हे टी आणि हे टी कॅन्सल होईल. Then we will get the next equation ds is equal to, हे जे आहे ds equal dq upon t, हे तर एंट्रोपी ऑफ इक्वेशन ऑफ एंट्रोपी आहे त्यामुळे आपण तिथे लिहिले. Here then we will get this ds, that is change in entropy, is equal to cv into dt upon t plus इथलं tt cancel r into dv upon v. For finite change of the state of a system, the entropy change delta S is obtained by integrating the above equation, integrating the equation between the limits of the initial state 1 and final state 2. म्हणजे याच्या अगोदर आपण बघितलं होतं इन्फिनाइटेसिमल स्मॉल चेंज, खूप कमी प्रमाणात चेंज असेल. आता एक फायनाइट ठराविक चेंज असेल तर त्यासाठी इक्वेशन आपल्याला जर व्हॅल्यू काढायची असेल चेंज इन एंट्रोपी और फायनाइट चेंज, मग आपल्याला त्या इक्वेशनचं काय घ्यावं, इंटिग्रेशन बिटवीन द लिमिट्स 1 and 2. देन द इंटिग्रेशन बिटवीन 1 and 2 ds is equal to cv into integration of t1 to t2 into dt upon t plus r into integration of v1 to v2 dv upon v. Then we get this equation by integration, that is S2, that is entropy of final state minus entropy of initial state, S2 minus S1 is equal to cv into ln. It is the integration ln t2 upon t1 plus r ln v2 upon v1. ln means log to the base n. Then delta S, that is change in entropy, S2 minus S1. Entropy of final state minus entropy of initial state means overall change in the entropy during this process, that is delta S is equal to cv into ln, this one into ln into t2 upon or log to the base n of t2 upon t1 plus rn r into log to the base n of v2 upon v1. This is the equation for 1 mole of an ideal gas, that is finite change in entropy between initial and final state is given by this equation. Now we will see the equation for 1 mole of an ideal gas, that is change in entropy, finite change for 1 mole of an gas. By putting this value, n means number of moles. जर आपल्याला 2 नंबर ऑफ मोल्स म्हणलं, 5 नंबर ऑफ मोल्स म्हणलं, तर यांच्या ठिकाणी ते 5, 2 जे काही व्हॅल्यू दिली असेल ती इथं आपण ठेवू शकतो. Then we can calculate the change in entropy during any process in which with the change in temperature and volume during initial and final state. Therefore, this equation delta S is equal to n into Cv into ln of T2 upon T1 plus R into L R gas constant, n is a number of moles, n into R into ln of V2 upon V1. This is the final equation for change in entropy with change in variables temperature and volume. So this is the overall equation for change in entropy with the variables or with change in temperature and volume. This is the equation 4 is the final and resultant equation. It is useful to calculate the change in entropy in process involving change in temperature and volume. So student, we will stop here. If you like this video, please like it, comments below this video and subscribe. So thank you very much for your kind attention. Thank you very much.